Hi student, welcome to this new video, still focusing on Laplace transform. But right here, we want to use the Laplace transform to solve differential equation. Now, the Laplace transform offers you a method to solve the differential equation as follows. The first step is to compute the Laplace transform of each term in the differential equation, inserting the initial condition, right? Secondly, you have to algebraically rearrange the equation to give the transform of the solution in terms of ys. This is the Laplace transform of the function y of t. And thirdly, finally, you have to invert the resulting Laplace transform ys to obtain the answer as a function of time. Now, remember that in the previous video, we show you that the Laplace transform of the first derivative of a function equals to s, the Laplace transform of f of t minus f of 0. And also that the Laplace transform of the second derivative of a function equals to s squared, Laplace transform of f of t minus f of sf of 0 minus f prime of 0. We call this 1 and we call this 2. Now, having the Laplace transform of first derivative and second derivative expressed as such, you are able to solve differential equation using the Laplace transform. Okay, after we have explained this, let's have an example. Solve the differential equation equals to 0 with y0 equals to 0 using the Laplace transform. Right. What do we do here? The first step is to compute the Laplace transform of each term in this equation. Sorry, here I have exponential 4t, right? Okay, find the Laplace transform of each term. Applying the Laplace transform on the left hand side and the right hand side, I will have that the Laplace transform of y prime minus 4 Laplace transform of y equal to Laplace transform of e for t. Okay, now what's the Laplace transform of the first derivative? Applying the formula 1 given here, right? I have that is equal to s Laplace transform of y of t, which is ys minus 4ys, which is equals to Laplace transform of exponential 4t. Now, if you remember, we said that the Laplace transform of exponential et equals to 1 s minus a when s is greater than a. So we see that the Laplace transform of e for t will be equal to 1 over s minus 4. Just applying this formula. So I have that is 1 s minus 4. Right. Now, this will give me s minus 4 y s equals to 1 s minus 4, which lead to Laplace transform of y, that s equals to 1 s minus 4 squared. So we have applied the first step to compute the Laplace transform of each term. Now we have also applied the second step, that is to algebraically rearrange the equation to give the transform of the Laplace ys, which is here. Now the third step will be to invert the resulting Laplace transform ys to obtain the answer as a function of time. How do we find the Laplace transform of such a how do we find the invert the Laplace transform of such a Laplace function? Now, remember what we saw when we talk about the first shift theorem, right? We said in the first shift theorem that Laplace transform of f of t times exponential et equal to fs minus a, right? That is, we know that from this, we know that the Laplace transform of t, right, equals to 1 over s squared, right? And we also know that the Laplace transform of is exponential et equal to 1 s over s minus a with s superior to a. Now, applying the first shift theorem, that says that the Laplace transform of a function of t multiplied by exponential at equals to the Laplace transform of the function of t, where we substitute the s by s minus a. That is, we will have that the Laplace transform, right? We will have that the inverse of this Laplace transform of ys, right, will give me, which is the inverse of the Laplace transform of 1s minus 4 squared will equal to t exponential 4t. Okay, so having this t times exponential 4t, we see that finally we have our answer y of t, which is equal to t exponential 4t. So in this video, we saw the 3 steps that we use or apply to find the solution of a differential equation using the Laplace transformation. We hope that you find this video helpful, and then you will use the methodology to solve more of differential equation of second or third order. Thank you very much.